In this video we will shortly explain the principles and functionality of edge detection. First we will go through the basic theory, and then show an example. Finally we will demonstrate the practical use of edge detection. Edge detection is a set of mathematical methods aiming to identify sharp, local changes in intensity in an image. These changes, which identify the edge pixels, are found using the image gradient. Using the image gradient, we find the edge strength and direction at a certain location of the image. The result is defined as a vector which has the important geometrical property that it points in the direction of the greatest rate of change of the image at the given location. The gradient direction is given by the inverse tangent of the partial derivatives, which is orthogonal to the edge direction. Here is an example of using the gradient to determine edge strength and direction at a point. Each square in the figure represents 1 pixel. For practical edge detecting, a filter such as the Sobel filter is used. The filter consists of a smoothing part to reduce noise, and a differencing part to enhance discontinuities. The Sobel mask looks like this, and can be used in both horizontal and vertical direction. We will now show you a sample of edge detection. The matrix to the left is a grayscale 3x3 image. We will execute a convolution filter using the filter matrix to the right. This matrix will give you the gradient in the image in Y direction. The filtering is done by taking the filter matrix and place it above every pixel of the image one at a time. For every pixel, the dot product is taken of the matrix and the pixels underneath. In the image we filter the middle pixel of the image. It is important to notice that there is a problem with this filter. Let us filter the pixels on the edge. We now have trouble. One solution is called padding. This consists of copying the edge element and create new elements around the image. You can see that the image is now filtered without any grief. Now we will show the gradient filter in practice using MATLAB. The picture you see is of a farm in Trondheim, and we want to be able to figure out where the farm vehicles have driven before. We have a function that runs a picture through a convolution filter. By using these two matrices as input, we get a gradient filter, and the resulting picture will be a grayscale of the gradient in X and Y direction. This is the function executing the convolution filter. We can see there are two for loops which iterates the pixels of the image. Then there are two inner for loops iterating the filter matrix for every pixel. The values of the pixels and matrix elements are accumulated and entered into the current pixel. We will now see the result of the filtered farm picture. Note that the gradient levels have been thresholded in order to get a binary picture.